Our project contributes to sustainability in many ways. It enriches soil, since it keeps it wet and ready for the seeds and roots to develop. Water. It saves water since the SAPs absorb great amounts of liquid for long periods. Air. And it helps air to produce oxygen when the plants grow thanks to the SAPs. We base on the fact that Accepta 4302, or superabsorbent polymers, are exceptional water retainers, and the idea that if we use superabsorbent polymers, we will improve the plant's growth and we will decrease the production and materials. Previous statistics show that SAPs benefit plants in the way that water delays its evaporation. This would mean that water would be retained for longer periods of time and it would be fully exploited. SAP can improve seed germination, contain potassium, save irrigation, and improve the soil water, and increase crops and fruit yield for a 70%. First, we observed how much water plants need and how long they take to grow. From that, we did the research of which object would help us to improve the planting conditions, and we found out about the use of Accepta, SAPs. Then, we established our hypothesis, that is, if we use SAPs in Group A, the seeds of Group A will grow faster and need less water than the ones in Group B. Then, we bought what was necessary and tried to test our hypothesis. At last, we get conclusions and share them in a video. For our prototype, we planned using plastic bottles. We are not only reusing, but because of its transparency, we'll be able to observe better the soil and the polymers. We will get soil because it will hold the roots and that provide supports for plants and store nutrients. We chose getting bean seeds because they are one of the most basic plants to plant. They tolerate a wide range of temperatures and they are easy to cultivate. The Accepta SAPs is the core of our project, so we got it from diapers. They will work as water retainers that will help with the soil. Cutting the bottles, the next thing we need to do is cut the diapers so we can take out the SAPs. Ya. No, porque le corté mal.
We're going to put water in the SAPs.
We're going to fill the control group with 2 little bottles and 1 big bottle with soil. Now we're going to make the control group. We're going to fill 2 little bottles and 1 big bottle with soil.
¿Se pudo o no?
Sí, se pudo.
Al final así quedaron, todo eso son polímeros.
Place the bean seeds in the bottles.
Now for the experimental group, we are going to put polymers in the soil and mix it. Now we have to put the beans in the experimental group bottles.
Our purpose with this project is that we reduce water at agriculture fields, and as plants grow, we promote the production of oxygen. The group we're aiming is the farmers, so they can use SAPs in their production, but this can also be used for anyone who has a plant or is interested in planting. In conclusion, we could observe that our prototype is showing all the characteristics we were expecting from it. The experimental group with the SAPs grew faster and needed of less water than the control group. I was in charge of recording, investigating, editing this video, and taking care of the plants.
This project will help very much to the sustainability, because sustainability means that we can have the elements or things that we have right now and that can still be in the future generations. So we think that the polymers will help to the growth and to the sustainability of water. With this project, I help with the diapers, I help with investigation, I help with bean seeds, and I help with the development of this project.
I could appreciate that the plants of the experimental group grow faster and bigger. These are the ones with the polymers. I could also see that with this project we can save water because we don't have to water our plants more often. For this project, I bring soil and some bottles and help with the development of the project.